Hello, this is Mr. McLeod, and we're continuing this series where I'm creating this treasure grab game. And so far, the game is coming along nicely. We got all the layout. We can move the player around. The edge looping works, and we can pick up coins. There's no sound yet, and there's no enemies. And there's no score. So if you remember I think the other version had a score thing up here. So we're gonna go ahead and I think the next thing we're gonna add in is the sound for the coins, and then we're gonna add in the enemies, I think. So the sound for the coins is actually pretty simple. If we just go into the coin class, we just need to play a sound. So if you go to the Greenfoot class, so if you remember, if you went to looked up the Greenfoot API, which you can also get by going up here to help Greenfoot class documentation, then we can click on Greenfoot, and down here, there's this play sound method. And the expectation here is that you can just give the file name if it's located in the sounds directory. Okay, so if you remember when we were creating this project back here, we copied all the sounds into this sounds folder, okay, in the treasure grab project folder. So in here, we could say the name of any of these sounds and it will play that sound. So we're gonna copy this get gold sound. I'm just copying the name so that I don't type it wrong. Okay, and then down here, whenever I touch a player, I can remove the coin, and I can also play the sound. So because this method is a static method, right, this keyword right here, just like the other methods in the Greenfoot class, they're all static. So the way that you need to call it is you need to say the name of the class, Greenfoot, right, with a capital G, dot the method name, play sound, and then the parameter is java.lang.string. That's just the same as string, right? And so we just need to pass it a string. Okay, so in here, we can get a string by just putting quotes. Okay, anything we put in quotes is going to be a string. So if we pass a string that says getGold.wave, that's going to go look for a getGold.wave file in the sounds folder right here, and it will find it. Okay, so if we go back here and we now run this, and let me make sure I got computer sound turned on. There we go. I think it should be on now. Okay. So then when my guy runs over here and gets gold, it should play that sound. That's good. Okay. So let's go ahead and go to the next thing. So the next thing is we need to make these monsters. And so my idea is that I'm pretty sure that the other game is set up so that essentially we have like 2 monsters up here. I mean, we can lay them out however we want. You just need to plan out where we want them, right? So let's say we put like 2, let's put them in like nicely like mathematical like grid squares here. So that makes the calculation easy. So if we just go down 2, and then to the center of that square, we'll put one there. And then, yeah, let's do that. Okay, so we'll put one there, and then we'll do so that we kind of mirror this to here and then to the center. So we got 2 up there, and then let's put one like right here, and one right here on the other side, and then let's put one like here and here. Yeah, let's just mark them off like that. Okay, so here we go. And then we'll put a couple like over in the very corners over here. All right, so we got 1, 2, 3, 4, 5, 6, 7, 8 of them. That should be plenty. Okay, and then each monster is going to be one of these images. So if we go to the image folder here, okay, so each of these is either going to be a skeleton or a zombie. Effectively, they're going to behave the same. They're just going to have a different image. So the way I can do that is that I can just go, when I create the subclass, I'm actually not going to pick an image. Instead, I'm just going to call this monster. And then in the monster class, let's see. Okay, for now, I'm going to clear those. I can get them back later. Okay, so in the monster class, we are going to have an act method, but we're also going to have what's called a constructor. So I'm going to say public monster, and this is the method that you call when you create a monster, right? Say new monster, and in here, in the constructor, I can decide what the image is going to be, right? So remember that we used constructors earlier when we made the coins and the walls, because we and I think even the player, like we initialize things, right? Like the size of the image, stuff like that. So in here, we're going to initialize the image to be an actual different image depending on chance, right? So we're going to say first, to show you how to get a random number, if you go back to the Greenfoot class again, this class also has a getRandomNumber method. So you can say greenfoot.getRandomNumber, and you can give it a number as the upper limit, and that's going to be from 0 to that number exclusive. Okay, so if we passed it like 2, then it would be either 0 or 1. So we could use that as kind of a Boolean value, right? So we could say if greenfoot.getRandomNumber 2, if it's 0, then we're going to make a skeleton. Okay. Otherwise, we'll make a zombie. Okay. So then, similar to how we did the sounds, for the images, we just need to make sure that in our images folder, inside the project folder, we can find, there's the name of the images, right? So one of them is just skeleton.png, the other is zombie.png. So then if it's a skeleton, we can just say set image and then just in a string, right? Let me just show you where I'm getting this from. In the actor class. So if we go back here to the actor class, you can see it has a set image that takes a file name, and it'll just make the image of that actor be that image, right? That's in that file. Okay, but it has to be an image. So let's see if it says it in here. Yeah, see it says the file. Well, it's a little bit less clear here. It doesn't say that it has to be in the images folder, but it does. It needs to be in the images folder if you want to just say the file name. Okay, so if we just say skeleton.png, or if it's a zombie, we would say set image zombie.png. Okay, in quotes. Okay, so before we do anything else, we can just confirm that that works by just putting some monsters on the screen. And you can see every time I add a monster. So as I'm hovering it around, it's just this like Greenfoot. That's because it doesn't have an image yet. But as soon as I click here, the Greenfoot system basically says new monster, and then it runs that constructor, right? So then it picks one of the types of monsters randomly. Okay. And we can actually see these monsters are actually kind of big. I think these need to be probably about half the size that they are. So I'm also going to say get image dot scale, and I think if I would just want it to be basically like half of each dimension that it currently is, I can just say the scale I want is, well, actually here, to make it a little bit easier, I'm going to say Greenfoot. Oops, image equals get image. Okay, so then I can just say img dot scale, and I want the scale to be the original image dot get width over 2, and the original image dot get height over 2. Okay, and actually I can kind of confirm that that's about how I'd like them to be. If we just right click here and look at the properties of the image, go to details over here. So right now the image is like 32 by 46. Actually, just looked kind of big. Okay, well, let's try this. And actually, I don't want this to be in an if statement because I'm going to do this regardless of which image I did, right? Because I want them to all be the same size. Okay, so now let's see how that looks. Oh yeah, that looks like more like the little monsters that that we had. Maybe a little bit bigger. I could mess with the size a little bit. So like maybe we should make them like 2/3. Be careful. If you say, just to be clear here, if you said 2/3 like this times get width, you got to be careful because 2 divided by 3 in Java is going to be 0, right? Because it's going to divide this integer by this integer and then store it in an integer, right? In an int, which means it's going to chop off the decimal. So if it's 0.66666, just chops off all the 0.66666 and we're left with 0, right? So you generally want to do division last, or you can make sure that one of them is a decimal. But for now, I don't want to get into that too much right now, so we're just gonna leave it like this, right? 2/3. Okay, let's do that. So let's see how those look. Oh yeah, now they're basically like about the size of the player, right? Okay, that's about what I'd like. Okay, so then now I need to give them their behaviors. Okay, so what they're gonna do is they're gonna just be kind of wandering around. So I'm gonna give them a dx and a dy. And when they're created, we're gonna give them a random dx and dy. So we'll say dx equals Greenfoot dot get random number. And let's say their dx and dy is always like let's see. Actually, you know what? I'm gonna change my mind here. I'm actually gonna have them move using the turn method. Let me see. Should I do that? Nah, I'm gonna use dx dy. Yeah, this is good. Okay, so basically they're gonna have a dx dy that is between -3 and 3, and then sorry, whoops, hold on. I want it to be between -3 and 3. So if I can't actually send two numbers like this to get random number. So what I can do is the range between -3 and 3 is 6, right? So if I were to choose a number, and also this is gonna, this I want to be inclusive. So if I pick a number from 0 to 7, and then I subtract 3, the 7 is gonna be exclusive, and the 0 is gonna be inclusive. So then this will translate into -3 inclusive to 4 exclusive, which is the same as, since these are integers, -3 inclusive to 3 inclusive. Okay, so the key here is I get the range 0 to 7, which basically gives me the size of the range. And then I just subtracted 3 so that I got it shifted over to the right. Well, sorry, this is the size of the range, and then I shifted it over to translate it. Okay, so in the end, what I'm going to do here is I need to pick a number from 0 to 7 exclusive, right? And then subtract 3. Okay, so then I'm going to do the same thing. Oh, oops, need to type a capital N there. I'm going to do the same thing for y. So dy is also going to be some number from -3 to 3. Okay. And okay, so then every frame, I'm going to have them move by their random dx and dy. But I'm going to have them not go into the walls, right? Because we don't want them going into the walls. So essentially, they're going to have very similar movement to the player. except that they're able to move diagonally. And every frame, they're going to pick a new random way to move. Okay. Actually, you know what? I kind of do feel like, you know what? I think it might actually be easier if we just made them move in the direction that they are facing. So here's how that works. So that means all I really need is they start out going in some direction, right? And then every frame, they're going to turn a little bit, except that I'm going to make sure that every frame, they keep track of like the direction that they're going. So I'm going to say this is in direction they're going. And so we're going to basically change this to like a direction. And instead of -3 to 3, we need some angle from 0 to 360. So essentially, well, 0 to 359, right? So that they get an initial direction. Okay. The lesson that we just did on doing random numbers, though, is still useful, so I'm leaving that into the video. Okay, so their starting direction is going to be given by this. And actually, to ensure that okay, so the reason that I'm keeping track of direction here separately is that when they rotate, I don't want the images to actually rotate. I just want the creature to like move a little bit in that direction, but then stay in the same orientation for the image. So the way I can do that is every frame, they're going to set rotation to whatever direction they're supposed to be going in, okay? But before I do that, I'm gonna change the direction by some amount, and that's where the plus or minus like 3 degrees, we'll use 3 degrees again, or 3, we'll use random number from -3 to 3 again. So Greenfoot dot get random number 7 and then -3. So this is gonna work out to -3 to 3, just like before. Oops. Okay, so then this will allow us to know which direction we should set the rotation to. So we set it to that direction. And then we're going to move speed, which I'm going to give a speed up here. Okay, and then we're going to initialize it to 1, 2. Okay. Okay, so then it's going to move this speed, right, in whatever direction deer is. But after I move the speed, I want to set the rotation back to 0 again. Okay, so what that's going to do is rotation 0 is the starting rotation. So that means it's kind of like it rotates and then moves and then like rotates back again. So what the user is going to see is that at the end of the frame, they're at rotation 0, so the user isn't going to see any rotation. Okay. I think we actually want to test this part first. So let's go ahead and test this. So if I add a monster somewhere, and then I hit run, it should be like moving all over the place somewhat randomly. Good. Okay, but it like turns every once in a while. So if I give like, if I make a bunch of monsters, whoops, I moved the coin. Okay, I made a bunch of monsters. If I hit run, then they're gonna be like moving all over the place, right? Okay, so then I just need to, so now I just need to make them bounce off the walls, or, you know, like avoid the walls. Okay, so that's actually pretty simple. So if I'm touching a wall, okay, so let me just actually, so is touching is in the actor class, right? I think we did this with coins, right? So we did is touching, right? So is touching, we need to pass it wall.class, right? Okay, so let's do that. Okay, so if is touching wall.class that we send, so that we're interested in whether or not we're touching a another actor that is of type wall. If that's true, then we're going to we want to turn 180, right? But to turn 180, we can't just say turn, because we have our own little custom direction variable that's keeping track of like the real direction that this guy is moving in. So what we need to do is say, we could say direction minus equals 180. And I'm pretty sure that set rotation is perfectly fine handling negative or positive values, but yeah, so let's leave it at that for now. Okay, and then we also want to make sure that, because if we do this, I'm pretty sure this will work like pretty good, but there might be some edge cases where it gets trapped in a wall. Let's try if we run this. That's it. This is going to be pretty good, actually. It's probably good enough, actually. Okay, so if they run into a wall, they basically like turn around. Okay, and you can see some of them have disappeared, and those are the ones that have managed to wander into the exits, and then they're right now they're not edge looping, right? Oh yeah, see, this is the issue that I was worried about. Right here, where he keeps spazzing out on the wall. So what's happening there is that he's in the wall, and turning 180 didn't get him out, because then he also turned a random 3 degrees, and then once he's not out, then he'll never get out. So that he just keeps on turning 180 and it just spazzes out. So I think we need to do a better job of that. Oops. Okay, so let's go back here. Let's rethink our strategy here, so that the most important thing when we run into a wall is that we want to make sure that we're not in the wall by the end of the frame, right? So one thing we can do is we can assume that when he first moved, he wasn't in the wall. So if we just found out that, so if before we set rotation here, oh yeah, that's the other problem. Holy smokes, that's actually terrible. Okay, I was setting rotation back to 0, and then letting them stay in the wall. Okay, let's get them out of the wall like before the frame is over. So I think we still probably want to like turn them around. But before we do that, I think if we just move negative speed, then that's gonna back them up so that whatever they did here, they're gonna like back out to where they were before they hit the wall. And then from there, they can turn around. Okay, so then that way, at least they're out of the wall by the time. Oh, whoops. Let's add some monsters in here. Okay, just adding a bunch so that if there's any problems, it will be more likely to pop up. Okay, so assuming, all right, so we hit run here. These guys, yeah, so see now they're no longer gonna get stuck, I'm pretty sure, because once if they ever go in a wall, they go back out to the place they were before they went into the wall. There we go, that's much better. Okay, I think that's, okay. All right, so now let's add in the edge loop. So for the edge loop here, we're actually going to use set location. So first, we need to define like when they edge loop, and let's just say when they're halfway across the edge. So basically, when the center, their actual position is at the edge. So if we do that, then we can just say like if actually we'll say if their edge is, if the center is past the edge. Okay, so if get x is less than 0, then we're going to set their position to the opposite side, so get width, and then the same y. Okay, and then else if get x is greater than get width. Okay, and so if it's past the right edge, then we set location to 0 and get y. Okay, and then we're not going to do an else if here, although there aren't actually any corners in this case, but I'm going to just separately, because if we wanted this to work, even if they went off a corner, we should technically check x and y separately. So if y is less than 0, then we're going to say get x is going to be the same, and we want to set it to get to get world dot get height. And I just realized I did not do that here. So these should be, remember that we're in the actor class, so to get, we need to get the world and then get the width, right? So let's put that in here. Okay, so we got okay, and then for this one, if get y is less than 0, we set location to the same x, but get world dot get height. And if get y is greater than get world dot get height, then we set it to get x 0. Okay, actually copy pasting and then editing is actually a little bit dangerous here because we might forget to change everything. So let's confirm that we changed everything here. So if it's above the left edge, sorry, if it's above the top edge, then we set location to the same x position and the bottom edge. if it's below the bottom edge, then we set location to the same X and 0. Okay, I think this is gonna be good. I think this one looked good. Okay, let's try this out. So just gonna put a few monsters out here, put a few of them down in there so they'll edge loop right away. Okay, that's plenty of monsters. Okay, we're gonna hit run. And okay, we actually see that there is a problem right away. So this guy at the bottom is having trouble getting through. Why is this one stuck? Oh, I know why. Okay, that's actually not a problem. That's because I actually spawned him inside the wall. And if you remember, our wall bouncing code depended on him at least previously not being in the wall. So, okay. So wait, okay, so the edge loop going left this way definitely worked. Okay, that way worked. Let me see, I wanna see a guy going through this way. Is this way gonna work? Oh, yep, I just saw a guy go through. Okay. Oh, I see, they keep hitting the wall and then turning around, that's why. So it's tricky for them to go through, but they can get through. I kind of wonder if we should widen this up because, oh, there, that guy just went this way. And, oh, there we go. And that guy just went that way. Okay, so actually all the walls, all the edge loops are working. It's just that they often will hit a wall and bounce. If they hit a wall, then they kind of like always turn around. It's like this guy is going like spazzing out back and forth with the walls. That actually could be a nice feature because then they're kind of guarding that wall. If we wanted to eliminate that, what we could do is make it so that instead of like turning around when they hit a wall, they just like back off of it. But that would have a different behavior. So then they would also be like, I think, a less mobile. They'd be more likely to hang out just like at the wall. So I think I like it the way it is. All right, I think that's good enough. Okay, so we got these guys wandering around. So now we need to make them interact with the player. So first, we want them to, we want them to growl if they're close to the player. And we want them to kill the player if they touch it, the player, okay? So, and for the touching, that's actually kind of, you have a choice, right? You can either have the player checking to see if it's touching a monster, or you can have the monster checking to see if it's touching a player. Since the monster isn't actually going to do any action when he touches the player, it's only the player that's going to do the action, namely dying. I'm actually thinking that it'd be better to have that in the player. Okay, so in the player right here, we're going to add some code that checks to see if it's touching a monster. I kind of feel like this huge block of code is like, I'm going to call this respond to user input, because that's basically what it's doing. It's like responding to the user input. I'm gonna make that a separate method. So that it will be easier to read my act method. Okay, we can just put all that in here and it's just gonna run that. We could, yeah, that's good enough for now. Okay, so we're going to respond to user input, and then we're going to check, like, we could call this like check collisions, or yeah. Okay. So we'll make public void check collision. And in check collision, we're gonna like check and see if we're touching a monster. And if so, we're gonna make the death sound, and we're gonna change the player's image. And we're also gonna record that the player is dead. So right now, we need to add an instance variable up here, is dead, and we'll set is dead to false in the beginning, and then change it when we get in here. Okay, so first we can say if, and let's just go ahead and use the is touching. There's no reason not to. So if is touching monster dot class, that means the player is touching a monster. Then we're going to set image to, actually, what if we just did die? Okay, so we're gonna say like public void die, and what die does is it makes the player dead, which is two things, right? So that we guarantee there's like a correlation between is dead and the image. Okay, so first is dead is gonna get set to true, and then the image is gonna get set to this image here, right? So we had in the images folder, it's literally called dead.png right here. Okay, so pretty simple, dead.png. Okay, and then we also need to make sure that the user isn't going to respond to user input or do anything else in the act method if they're dead, right? So if not is dead, oops, then we do all this stuff, right? Let's do this. Oops. Okay. Okay, so if they're not dead, then they do stuff. Okay, let's leave it at that for now. And let's add some monsters. Later, we'll do the layout. I know I spent a little time in the beginning thinking about how I'd lay them out, but why don't we just put them randomly for now? Okay, so then if the player, boom. Oh, interesting. Okay, so remember we set the image size of the player to 32 by 32, but then if they die, it just loads this image as the default size, right? And let me go look at how big that image is, whether or not setting it to, let's see, oh, it's pretty close. Let's see, so it's 62 by 34. So the 62 is the one that's too big. So what if we just changed it? I think if we just like divided it by 2, that would be pretty good. Okay, so let's just do that like we did with the monsters, kind of. So we want to set the image to dead.png. By the way, in some ways it might be simpler if you just like went to an editor and like changed the size of the image. That would also work. But in here we can always we can just say scale, right? So we need to get image, and since I just changed the image to dead.png, then when I get image, it's going to be the new image, right? And then I can say scale. And basically I want the width, let's do it this way. Well, it's okay, we can do it in one line. This is going to be a little bit long. So get image dot get width, whatever that used to be, divided by 2. And then get image dot get height divided by 2. Okay, so it'll just be like half the size. Let's see how that looks. Oh, whoops. Better get some monsters. There we go. Oh yeah, that looks good. Okay. And then we also wanted to play the death song, or the death sound. So we can say Greenfoot dot play sound, and the name of that sound is, whoops, down here in images, we go back and to the project portal, we open sounds, and it's death.wave. Okay, pretty simple. Let's go back here. Okay, sound is going to be death.wave. Okay, oops, add those monsters. Actually kind of nice if I just added them permanently in a little bit. Oh, there we go. Nice. That's a satisfying sound. Oh, that's just like unfair. Let's move him a little bit. Oh, even that was pretty unfair. He got toasted right away. Okay. So I feel like those guys actually move a lot faster than the original game. I think this game is going to be a harder. Okay. So now we need to add the feature where the monsters were going to growl whenever they're close to the player. So let's look in the actor class, and whoops, go up here and you look through the methods here. Check this out. This is like practically made for this purpose. Look at that. Right here, get neighbors, returns the neighbors to this object within a given distance. Yeah, that seems like exactly. Oh wait, what's the difference between? Oh wait, neighbors is different. I think, hold on. I think we might want objects in range. Neighbors only considers only logical location, ignoring the extent of the image. Thus, it's most useful if they're contained in a single cell. Okay, this doesn't really sound exactly like what we want. This would be if you had like a very grid-like game. Okay, so what we actually want, I think, was that second one. Get objects in range, because this is going to return a list of all the objects within a certain range. So notice there's one important thing about this, which is that it returns a list. So a list is like an array that we, so let's take a look at how we would use this one. So in the, and effectively what we want to know, because we're going to pass it like the type of object we're interested in. So since there's only one player, this list is always going to either have one thing in it or nothing. So that actually makes it pretty simple. We don't even have to access the items in the list. We just check and see if there's anything in the list. Okay, so that's going to be pretty simple. Okay, so if you notice here, we got java.util.list. This is the type of thing that it returns. So let's go back out here And if we Google that, you'll see the API for list. And if you go down here, we want to know basically like, is there something in it? So notice that lists have this method called size. This tells you like how many things are in the list. So if we just got a list of all the player objects that are within range, if there's at least one item in that list, then the player is there, right? And we can make the sound. Okay, so I think that's going to be my plan. All right, so in the monster class, see, I kind of feel like we should put this also separate these out. So let's say this is going to be public void edge loop. It's kind of nice to like separate them by behaviors, because then if you want to turn off certain behaviors or override them in a subclass, it makes it easier if it's a method here. And then this is like the movement. We'll just make a move with no parameters, and then we'll make an edge loop. Okay, so this is going to be public void move with no parameters. Okay, remember there was moves that took parameters, but there wasn't a move with no parameters. So this is, as far as Java's concerned, this is a completely different method. Okay, and it's going to do that. Okay, so not to be confused with move int, which takes an int. That's a different method. When you have two methods with the same name, that's called overloading. Okay, method overloading. Okay, so this kind of makes the act method a lot more readable, right? We move and we edge loop. And then here we're going to, we'll just say like growl at nearby player. Okay, and so that would only growl if there is a nearby player. So we say public void growl at nearby player. And we're going to do that if there is one. So in here, we're going to say if, actually, I'm going to do it in 2 steps. So first, we need to make actually, no, I'm going to do it in 1. Okay, so we can say if, and then in the, yeah, you know what? I am going to do it in 2 steps because I do want to show you guys how to use list a little bit here. So we're going to say list, and if we go back at the actor class, remember that this was, this is going to be a list A. And to understand what this A is, if we go to the list class, you can see that corresponds to this E, which tells you the type of elements in this list, right? So then again, if we go back here, notice that this A matches the A in java.lang.class, okay? So in the class, this A represents like what kind of class is it representing. So bottom line is, if we pass it player.class here, then the A will be player. And so this will be a list of players. So then in the monster class here, we can say list of player objects. Let's call it plist equals, and then we call the method, right? Get objects in range. Just copy that. What's the monster class? Okay, so get objects in range, and then we need to pass it a radius, right? Like how far are we going to look? So each tile was like 32, but this is going to start in the center of the player, sorry, in the center of the monster. So it's going to take, you know, we could say it's like 16 just out to the edge. So we probably want to go at least, if we want it to be like a full square away, maybe we could do like 48, so that it's like 16 plus another 32. We could mess around with that a bit. If you want a nice round number, we could put like 50. And then we're going to say here player.class. Okay, so we're going to get any objects within 50 that are players, and they're going to get into this list, plist. And just so you know, if you wanted to do something with this, before we get into this, okay, so because we said list here, it's going to look for the list class, but we haven't imported it. So we need to go and look and see that this is java.util, and then the class is list. So the package and the class name together, we need to import java.util.list. Okay, and so that way when I say list, it knows I'm talking about the one that's in java.util, because there actually could be other lists. In fact, there is in the java.awt package. Okay, so now we got this list. So then if we just wanted to check if there's something in it, I get to say if plist.size is greater than 0, then that means there is a player close by. So then we're going to play the sound. Greenfoot dot play sound. And I'm gonna just call this growl for now, because we're actually gonna like get a random growl. So let's say Greenfoot dot get random number. And then let's take a look at the sounds that we have, because we actually have several sounds. Okay, so in the sounds folder, I have growl 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So there's like 9 different sounds. So if I were to pick a number from 0 to 10 exclusive, that would be 0 to 9 exclusive, that would be 9 different numbers, right? 0 starting at 0 up through 8. And then I would want to like offset it by 1 so that I get a number from 1 to 9. And if you looked at the sound files, they're all named like the same thing with like a number following it, right? So they're all like growl 1, growl 2, growl 3. So then I could get the growl by saying, so I make a variable of type string, right? Because it has to be the string for the file name. And it's going to be starting with growl. Okay, and then it's going to have the number. Let's call this num. Okay, and then plus dot wave, right? Because they all end in dot wave. If we go back and look here, so they're all like growl 1 dot wave, growl 2 dot wave, and so forth. So now we basically picked a random number from 1 to 9 to be like which growl it's going to be. Okay, and then we just play that sound. Okay, let's try that. So I'll just like put a couple monsters here. Hit run. Oh, well, he growled, but then he killed me. Oh, actually, check it out. They're gonna still growl. I think I need to, yeah, see, I think I need to extend that range. 50 is too small. Let's do that. Let's make it like 75. Let's try that. Because it didn't growl until it was like practically on top of me. Wait, what's going on here? Come on, seriously. Okay. Oh, there we go. I don't know why that took so long. Okay, so we got a couple monsters here. Let's hit run. There we go. See, now I can get close to them and they growl at me. And I think what's happening there, like it's growling like every single frame. So it's like kind of mashing all the sounds together. So I think what we need to do is make it so that there's a cooldown on that sound. So let's do this. Let's just write cooldown. If we had more things to cool down, then we might make it something else, but okay. So we have a variable that's gonna like keep track of the cooldown, and we'll start out with the cooldown is 0. And then if we growl, we're gonna increase the cooldown. Let's set it to like 30. Start with that. Actually, let's set it to 50. Okay, and then like it's gonna wait this many frames before it goes. Not because I just said cooldown equals 50, but because we're gonna set cooldown to 50, and then we're only gonna do this growling if the cooldown is 0. Okay. And then we're only going to and then so if the cooldown is 0, we do this, right? Otherwise, we can reduce cooldown, right? So then it gets set to 50, and then it'll count down 49, 48, 47, all the way down to 0. And then when it's at 0 again, it'll start doing this again, right? Okay. So let's try that. So that way we won't just like, oh, whoops, gotta put a bunch of monsters here. Okay, so let's hit run. There we go. Ah, yeah, see, now they're all saying different things. Okay. So this is great. Okay, so I think the last thing for these monsters that I want to do is actually place them in the world. So I think we're just gonna like place them around in specific places, like it was in the game there. Okay, so place monsters. Okay, so we wanted like let's put like, I'm just gonna like, I don't care what I wrote before. I'm gonna just put like 2 of them here. Okay, so then that means it's like 1, 2, 3, and then we got to go to the middle, right? 3.5. Okay, so all right, so we're gonna say monster 1. Actually, I kind of feel like this should be like a helper method. Place monsters. Okay, and then down here I can just like do that public void place monsters. Okay. You know what? I'm kind of lazy. What if we just, because I've done a lot of layout already, what if we just like did a random layout? Okay, so here's what I'm thinking. Like basically there's, so then we can place as many monsters as we want, but like in kind of random places. So what if basically they can spawn anywhere in these boxes where the coins are. Let's go back here and draw this. Okay, or okay, so like in these coin boxes, anywhere along here, including on the edge of the coins. That makes it nice and simple. And then also anywhere on this top area, like, but this box right here. Okay, so that would mean if we establish our boundaries, the upper left corner of this is going to be like 2 wall widths to the right, okay, and 2 wall widths down. Okay, so that's like right here is 2 wall widths to the right and 2 wall widths down. So that's like the upper left corner of this rectangle, and then the rectangle itself is 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's right. So 5 by 11. Okay. So you can say this is like 11 by 5. And then we can see that this is like 1, 2, 3, 4, 5, 6. So this is like 6. 6 by, I'm going to say 3. So we're just going to go only down to here. Actually, you know what? I'm only going to go to here because I don't want to. I want to make sure that no matter what, it's not going to like go in any walls. That's my main concern. Is I don't want any guys spawning in the wall, right? Okay, so that means this is actually going to be 6 by 2. Okay, so this will be 6 by 2, and then this is going to be another 5 by 11 with an upper left corner of well, we could just say this was 2 wall widths, and then another 5 and 6 is 11. Actually, let's do it from the left side here. So this is 1, 2, 3, 4, 5, 6, 7, right? Because this was 5, and then it's 2 away. Okay, so this is 7. Everything's in wall widths. So I'm just going to say this is 7 by 2. Okay. All right, so that should be everything we need to write the code for that. So let's open up the world class again, and let's work it out here. Okay, so we've got int so what I'm going to do is first I'm going to pick which area they're going to be in. Okay, so they're going to be, and I think what I'll do is we'll have like 2 monsters in the middle area somewhere in here, and then there'll be like 4 monsters. Actually, that's probably too many. I was gonna make the game super hard. Maybe we'll just put like 1 monster in here and then 2 in each of these places. Let's start with that and see how that is. Maybe even like 3 in these ones. Okay. Yeah, we can try that. 3 and 2. There we go. So that'll be a total of like 8 monsters. That should be pretty challenging, and we can always make it easier. Okay, so first, we're gonna place, yeah, so in that case, we don't have to like pick which area. We just like, we're gonna make 3 in here, and then 3 in here, and then 2 in here. Okay, so left area, we're gonna say for 3 times, right? In a loop, we're gonna pick a monster position in this box, right? So X is gonna be some, I kind of feel like it would be useful at this point to just like make a general random num method here that has like a x, a min, and a max. And let's just like, then we can just keep using that helper method. Okay, so to do that, basically, we want the size to be max minus min, and then +1 because it's exclusive, right? So let's take that as an example here. If we had min was 3 and this was 7, then the range would be 7 minus 3 plus 1. So then that's going to be 5. So if I picked a number from 0 to 5 exclusive, then that would be the same as 0 to 4 inclusive. Okay, so then this would be inclusive. Sorry if this is not clearly, it's kind of hard to draw that. Okay, so this will be the same as 0 to 4 inclusive. And so then if I just added 3, then it would give me a range from 3 to 7 inclusive. Okay, so all I have to do is I get the right range, and then offset it by the min. Okay, so at this point, I think I can just do it here. Okay, so let's erase this, it's kind of in the way. Okay, so then, and I want to return a random number, so sorry about that. And in particular, I want a random int. Okay, so I'm going to say return Greenfoot get random number, and I want to pick a random number in that with that size of the range, right? Max minus min +1, and then I want to add the min to offset it. Okay, I mean, I could have done it all in one line, but I wanted to break it down for you guys. Okay, so there we go. I've got now a general random number between two numbers kind of method. Okay, that'll come in handy. Oops, I need to write this. Okay, so now we're going to say x is going to be a random int between 2 times, oh, wait, hold on. I think you know what? It's going to be, since I made these, okay, so I'm going to have to make this wall model. Sorry about that. Let's pick this wall model, because we used the wall model to like get the wall width and stuff. I guess that would have been a nice reason to leave all this in the constructor, but that's okay. I can just reproduce this. Pretty simple. Okay, so we got to get our model wall. So we have the wall widths because everything's measured in wall widths. Okay, so we're going to say 2 times wall width is the minimum, and then the maximum is, this is length 7, so this will be, sorry, this is length 5, so 2 plus 5, so it'll be like 7. Oh, whoops. Okay, so 7 times wall width. Okay, and that'll be the x. Okay, and then we just do the same thing with the y, right? Int y is going to equal random int between, I'm going to expand this actually so you guys can see. Okay, so the Y value is also between 2 times wall width, so wait, wall height, and this time it's 2 plus 11, so 13 times wall height. Okay, and then I can just say, let's place it there. So I need to make a new monster. So monster equals a new monster, and then add object, the monster at X, Y. Okay. All right, so then we're gonna do the same kind of thing again on the right side. Okay, right area. Okay, it's pretty much gonna be the same, just with different ranges. Okay, so the right area, we're gonna do 3. This time it's gonna be get width minus so the minimum is actually going to be get width minus 7 wall width, right? And the maximum will just be get width minus 2 times wall width. Okay, so minimum here, maximum here. Okay, all right, and then we just do the same thing vertically, right? So we got our minimum. Actually, the minimum for vertical and maximum for vertical is going to be exactly the same. Great, perfect. Okay, so we've got 3 monsters in the left area, 3 in the right area, and then we want 2 in the middle area. So we're going to say we'll go ahead and do this again, even though it's just a for loop that repeats twice. That's okay. So 2 times, we're going to pick a random number. This time it's going to be minimum. Oh wait, I should just do it this one, because this is going to be based on minimum is going to be 7 times wall width, and maximum is going to be 6 further than that. So that's 13 times wall width. And then the Y will be 2 times wall width to 4 times wall width. Sorry, 2 times wall height, 4 times wall height. Okay, so we got minimum between here and here horizontally, and then between here and here vertically. Okay, and then we just make the monster. Okay, so we do that. Each time we hit run, so each time we hit reset, it should pick like a new, whoops, it should pick like a new set of monsters in different, and there's like 2 of them in that center area. And then it's like this guy is actually in the upper left corner of this area, I think, isn't he? Why does it seem like there's, wait, let me see this. Oh yeah. Yep. Okay. And then these guys are just like on the edge here. Okay. Yeah, we're good. Okay. So basically, each time we get random guys that are like in the areas, but they're not like on top of the player, and they're only in those specific areas. Okay, that's pretty good. So if we hit run, oh wow, this game actually is pretty hard with this many. I think I may have gone a little bit overboard with the number of monsters. Let's see. Oh yeah, I think I should probably put like 2 in each of the sections instead of like 3 in the big ones. Oh Oh gosh. It's like scary. Okay, well, that's okay. This is a hard game, but it's not impossible. I got stuck on that. I need to make that wall entrance bigger if I want to do this. Okay, and then oh, by the way, let's see. Yeah, I think you know what? I think that's good for this video. I think we're gonna stop right here, and we'll keep going on the next video. Okay. So I hope you're enjoying this series. And here we go. I'm gonna stop.